I'm here today to wrap up Unit 5 for us. We're on Lesson 5.4. We should be completing that corresponding page of the study guide. Remember that our test is an open note test, so you want to have that study guide as complete as possible and be using that for the test. Human impact is our lesson today. Not really everybody's favorite lesson. Some people get really excited about this one and inspired and glad that we're teaching this, and others don't like the idea of being told how terrible we are. This lesson can be kind of a tough one to swallow. We've had some precursor coming into this lesson. We've talked quite a bit already in class about some of the human impact on the environment, little pieces here and there. Today's lesson will revolve entirely around that topic. At the end of the class, we've got a whole nother unit, our very last unit, that actually kind of comes back around to human interaction with the ocean. And that negative impact will be a part of it. We'll also talk about positive impact as well. For today's lesson, it's not going to be too positive. All right, so the human impacts on climate, we're writing this down now in bold. Much of the increase in atmospheric CO2 is a direct result of human activity. Not all of it. It is a natural part of some of our processes that occur in nature. We have sped up the release of CO2 into the atmosphere. That's no secret. In recent decades, 75% of the increase is the result of burning coal, oil, and fossil fuels, but there are some other things as well. The rest of that increase has come from intensified land use. In particular, as agriculture expands in some countries around the world, including our own, the burning of forests and other plant matter, other biomass, the clearing out of areas in order to then use them as farmland, that emits quite a bit of CO2 into the air as well. The anthropogenic or human impact, just wanted to throw that fancy word in there for you. So we're still writing here, a lot to write here for this section. The main human sources of methane, we've mentioned this already in class, but now we get to go ahead and get it in writing. So methane, or it's fossil fuels, and then the digestive systems of cattle and sheep. They release methane when they flatulate, and the more that people are eating cattle around the world, the more cows there are, the demand rises for beef, then the number of cows that we're going to produce around the planet rises as well, and so the amount of methane that they're putting out is going to rise. That's a very serious concern that we need to be thinking about right now. Human emission of greenhouse gases are the only thing that can explain the rapid global climate change that has occurred in recent decades. There are lots of people who still would like to deny the reality of climate change, or would like to at least say that humans are not responsible, but the facts are facts. Yes, the climate has changed around the world before, but it is clearly beyond. I mean, we can look at the ways that climate has changed before. We have ways to look at it and to measure it, and where we're at now is far beyond what the world has done through natural processes. We have taken it to another level. Here's an example of that. The green represents what it would have done on its own, and the black in particular, represents where it is now. So again, far beyond natural processes of what would have happened. We are clearly having an impact on the CO2 level. All right. A little bit more to write for this box. Oceans have absorbed about 30% of our CO2. We actually talked about that in another lesson already, but just to reiterate, that increase, that CO2 that's being absorbed into the ocean, then makes the ocean more acidic. So less alkaline, more acidic, which that's its pH level, and that acidification is not good for a number of different creatures. I'm going to keep on going here. And last one, I think, here before our next box. That box probably should have been bigger. A lot to write in that one. The year 2014 was the warmest since record keeping started in 1880. It's December now. I probably should have checked to see where we were at with 2020. A number of months now in 2020 have been record breaking as well. There's a chance, I don't know off the top of my head, I'm just taking a guess here. I don't know if 2020 will beat 2014, but it will be pretty close as I understand it. 2020 has been a very warm year. We see on average, we see those global temperatures rising. The increase in atmospheric temperature also causes the temperature of the ocean to increase. I'm gonna keep on going for the sake of time and get to this part, sea level rise. This is our next box. So the warming oceans are causing sea levels to rise, meaning the water level itself to come up, for there to be more water in the ocean. This rise is due to the expansion of surface water as they warm. So not just more water from the melting ice, that is part of it, but also the heat expands, cold contracts, and so as these surface waters warm, they are expanding. The particles separate a little bit, and that causes a little bit of sea level rise as well, as well as the typical response that we would hear or think about. The idea of melting glaciers and ice caps, causing there to be actually literally more water. And that's going to cause sea level to rise as well. Approximately 50% of sea level rise so far is due to thermal expansion. That's that warming of the waters and it expanding. About 25% is due to glacier loss, and the rest is due to changes in features such as permafrost and ice caps. I won't go into a ton of detail there, but we do want you to get the next part. The latest studies predict that the sea level will rise between 0.26 meters and 0.98 meters. That's about 8 inches to about 3 feet is roughly the range in inches and feet. That's going to raise that much by the year 2100. So maybe for some of you within your lifetime. All right, moving to the next box here, climate change. Global warming is a less accurate term than global climate change. The term global climate change encompasses not just the temperature change, but really the full spectrum, the whole gamut of the predicted climate impacts. There's a lot of things that come with that global warming, and so global climate change does a better job of capturing the full picture. Let's go ahead and keep this in that same box, in that climate change box, and then we'll have a separate box for impact on marine life. So we want to go ahead and get all this down. Some changes brought about by global climate change may include more extreme storms, higher temperatures, increased uneven distribution of rainfall, glacial shrinkage and disappearance. Our glaciers are melting. Overall decrease in agricultural yields, meaning less crops, and that's not good as we see the population, the human population on the planet continue to grow, and then an increase in forest fires. We already have seen that. Watch the news and pay attention to what goes on out west, and particularly in California, and some other places around the world as well. But as far as the United States goes, we see a lot of it in California, and it has no doubt been increasing from what it ever has been in the past. Interesting note here that the first one there, the more extreme storms, there is some debate around that. There is some debate about whether maybe it will be more storms, but they're not going to be more intense, or maybe it'll be roughly the same amount of storms, but those storms that do come are going to be bigger and stronger. There is some debate around that, around all of this as well, but that one in particular I mentioned because we covered cyclonic storms in our last lesson. The impact of marine ecosystems. It's impossible to predict all the ways that climate change will impact marine organisms, but there are some things that we know already that we've been able to observe and study and to calculate. So some organisms are actually going to fare better. We talk about organisms that are going to be devastated by climate change. The fact is, some will actually be in better shape, but not in a way that's going to keep a good balance within our ecosystems. The scientists, conservationists, governments are working together to restore and protect a variety of resources. Last slide here. So a couple of the things that we do know or at least suspect. We've talked about this first one already because of acidification. Anything with a shell is already being negatively impacted. It takes more energy. The acidification of the ocean, it deteriorates the shells, and so they have to put more energy into maintaining those shells, and that gives them less available energy to be able to hunt for food and to reproduce. And so populations, we have already seen them start to shrink in some of these shelled organisms, and that we would expect is only going to get worse. Some organisms that might benefit include seagrasses and jellies for different reasons there, but these are two things that the warmer waters will be good for. And then this kind of a good and a bad, we will see some creatures thriving, but not in the places where they have normally thrived. We're going to see an increase in invasive species as different creatures have their own habitats destroyed and they move into new ecosystems. There is a chance that they will come in, not even a chance, there is a guarantee that there will be some examples of this where creatures come in, creatures that are not native to that particular ecosystem or habitat will come in and deplete the resources and throw off the balance of that ecosystem that has likely existed for a very long time. So lots of impacts that are coming from humans. And this is aside from all the trash that we've already talked about. This is just as far as what we're putting into the atmosphere and how it impacts things. So there are lots and lots of other ways that we're having a negative impact on the ocean as well. They're not to hurt your brains and to overwhelm you, but these are issues that we need to be taking seriously. How can we be reducing the amount of waste and trash and that kind of thing? How can we be reducing our carbon footprint so that we don't continue to see this rise in CO2 in the atmosphere? What are some of the things that we can be doing as individuals and as a society to try to balance some of this stuff out and make sure that that we don't destroy it all? There you go. There's the end of Unit 5. Test will be Thursday. Peace.